looking good.
All right. So thanks so much for having me here today. And as Richard mentioned, I'm one of the leaders and core developers of Project Jupyter. I got involved in Jupyter, I guess, before it even was Jupyter, back in 2004, 2005, when it was just IPython. And at the time, it was a terminal-based interactive programming environment for Python. And over the years, we've built the original Jupyter notebook that 2007, and then we eventually started to support more languages than Python, and have done a sort of an expansion of that, or spawned a new project called Jupyter that sort of has the language independent, language neutral parts of the architecture. And so IPython continues to exist today as the default and sort of reference kernel for Jupyter in Python, but then Jupyter continues to move forward with the goal of providing an architecture, services, and user interfaces for interactive computing across essentially all programming languages where that makes sense. And before I get started, I just want to emphasize that at this point, Project Jupyter is the work of numerous people. We have a steering council, that's the governance body for the project, of 12 individuals currently, all of whom have made long-term substantial contributions to the project. And then we have somewhere around 25 to 30 people working significantly on the project. A lot of those people are full-time, and our sort of core contributors span numerous US and European-based universities, as well as a number of for-profit companies. And so, you know, I'm here presenting the work of many, many people and organizations today. And I want to talk about a new effort that's been going on for the last 2 to 3 years, and is getting close to being released. And that is a new user interface that we're building that will eventually replace the classic Jupyter notebook. And this is called JupyterLab. And I'm showing my screen here, JupyterLab. And the big idea of JupyterLab really gets back to what we've observed from working with users since 2011 of the Jupyter notebook, and also of using it ourselves in a wide range of different settings. And I guess the way that I think about this is that the classic Jupyter notebook allowed us to sort of distill the fundamental building blocks required for interactive computing. By that, I mean a user needs a place to type code, a place to view output. Typically, or often, you need an actual full-blown terminal, a file browser, and obviously a place to actually run code. So the ability to connect to kernels, and then higher level abstractions such as notebooks that allow you to sort of take these lower level building blocks and assemble them into documents that can be shared with other people or be used to reproduce an analysis. And over time, we found that those building blocks were really useful, but that their expression in the classic notebook was very restrictive. It was restrictive, one, for people who wanted to extend the classic notebook. And the way I think about this is that we built the classic notebook back in 2011 when jQuery was state of the art. Web development was very primitive, and honestly, we never imagined that people would want to use our JavaScript as public APIs. And obviously, a lot has changed. And so the classic notebook's code base was very sort of difficult to work with, difficult to extend and build on top of and use those building blocks in different ways. The other is that users have expressed a need, and we've observed this, to assemble those building blocks in different ways. And so JupyterLab sort of has been developed over the past 2 to 3 years to address those needs. And I basically want to walk you through a demo of where JupyterLab is today. So this is what JupyterLab looks like when you pull it up. We've got a launcher here. The first is all the familiar building blocks that are in the classic notebook are already in JupyterLab. So on the left here, we have a side panel area. And actually, for this, I'm gonna, Max, can everyone still see that?
Yeah, looks good.
Yes. Oh, great. I wanted to make sure that the maximization didn't cause any trouble. So on the left here, we've got a side panel with a file browser. I'm in a folder on my local system here. You can see we've got some files, notebook files, image files, CSV files, and the main panel area, we call it the dock panel. There's a launcher and different activities. And so I can click on Python 3 to get a Python 3 notebook here. And indeed, it works just like you would expect the classic Jupyter notebook to work. I can click on the plus button here to get a new launcher. Maybe I want a terminal, and I get a full-blown terminal just like you would get in the classic notebook. Other things, for example, I can get a new text file. I can also sort of interact with the file browser and this dock panel area by just clicking on files. So here's a notebook file. I can double click on that notebook file. This particular notebook is from Jake Vanderplas's excellent Python Data Science Handbook. And again, the main reason I'm showing you this is just to illustrate that Jupyter notebooks are still Jupyter notebooks in JupyterLab. And it's important to note that the document format for Jupyter notebooks is completely identical in JupyterLab as a classic notebook. So all of your existing notebooks will work just fine. There's some fine print there. Some extensions to the classic Jupyter notebook don't work in JupyterLab and will need to be ported. And I can talk about that more. But again, Jupyter notebooks still look and run just like they always have. We've got these building blocks, but there's also some new building blocks that we're offering. And for example, here is a console style experience. So this is not a terminal like a bash terminal, but similar to the Qt console from that IPython and Jupyter have offered for a long time. And it basically is a different way of assembling the core building blocks of input and output. If you think about a notebook like this, so the notebook has both temporal ordering, in other words, the order in which the cells are run, and spatial ordering, the order in which the cells are viewed in the document. And notebooks, for better or for worse, don't synchronize the temporal and spatial ordering. And so actually, I can run this cell first and run the previous cell second, and then I have a situation where the spatial ordering and temporal ordering are offset. And you may think, like, I mean, a lot of people use the notebook and are used to this. In many respects, it can be confusing. On the other hand, the way I think of it is the notebook is really narrative, and we're all familiar with narratives, movies, books, where the temporal ordering is violated in the narrative, right? You can have flashbacks, things like that. So in a narrative context, it doesn't always make sense to have the temporal and spatial aspects synchronized. The console, on the other hand, necessarily synchronizes those two things. So the ordering of the cells that have been run in spatial order exactly matches their temporal ordering. And again, this is a different way of assembling these fundamental building blocks. And we find that users need different ways of working with these things for different types of workflows. For example, the console tends to work really well when you're just doing sort of scratch pad work, where you're not necessarily worried about building a narrative document that you're going to share with other people or record later. The console is also a lossy format, so there's no file that backs this. When you close the console, it is gone permanently. So that's another sort of way of assembling those same building blocks. The thing that I think is interesting, though, in JupyterLab is now we can provide integrations across those different building blocks. So, for example, here in the notebook, I can right-click on that and say Create Console for Notebook. Okay, and this is a weird bug that we have in full screen. And so now, actually, I've created a console that is attached to the notebook over here. So let me pull this off to the side. The other is that the dock panel provides a very flexible layout system. So now I have a notebook here. I've already imported NumPy, and so I can just say numpy.tab, and tab completion works. All the variables that are live in that kernel for that notebook are now available, and I can explore interactively in a sort of scratchpad way with the console. This dock panel is a fully two-dimensional hierarchical layout system, so you can arrange your content however you want. And so here we've got a text editor below a console, which is next to a notebook. We can also do other things such as the following. So here's a notebook. I can ask for a new view into that file, and then have two views of the same notebook side by side. And one of the things that we've done along with creating JupyterLab is think very carefully about the architecture in the front end to enable these features. One of the things that we've done is to specify sort of standardized APIs for models in the front end in a way that allows us to attach multiple views to those models. This feature here is one example of that sort of came for free with that design. Another example is the possibility of real-time collaboration that I'll talk about later. Other examples of that, let's go over here. So I can show you some other different file types that we handle. Here's a CSV file. If I double click on that, it opens up in a data grid viewer that we have. And I can see the usual iris data set. I can, let's see here. Actually, let's open up this Markdown file. So here's a Markdown file. And there's a single model of this Markdown file. Was there a question? I thought I heard someone say something.
I don't think so.
Okay. So here's a Markdown file. I can right-click and say Show Markdown Preview. And the thing, again, that's nice that is basically, it's something that we get for free, is that because there's a single model for both of these views, I can come in and this is live editing file. And once I stop typing for, I think it's a second, the Markdown automatically re-renders. And again, it's not something that we said, hey, let's implement a live Markdown viewer. It was simply a side effect of the underlying architectural decisions that we were making. To show you sort of...
Hey, Brian?
Yeah.
Hang on for just a second.
Yeah.
Rich, are you seeing... I sort of see a frozen screen from Brian. Are you guys seeing him?
I think that's just you then, because I'm seeing what, as he's typing. You didn't see the live editing?
It just is a little slow, just caught up. Thanks.
Okay, great. Let me know if there's any problems.
I just wanted to say that that's pretty cool. Okay, carry on. Sorry.
And actually, one of the fun things for us building this is to see the really fun side effects of these architectural decisions. And it actually took us, there was a period where we had implemented the architecture and hadn't yet fully realized what we could do with it. So for example, the architecture for this particular example existed for many months before we realized, hey, wait, we could do real-time Markdown editing. But it's been fun. I can also then right-click on the Markdown file and say create console for editor. Now I actually have a kernel attached to that Markdown file. And if I simply put my cursor on a triple backticks code block and type Shift-Enter, it sends that code to the console. And so we've got automatic block detection. And so I basically instantly we have support for running code interactively in Markdown documents. But again, there's nothing special about Markdown here. You can do the same thing for any file format, for restructured text, for LaTeX. We don't have automatic block detection in those other file formats, but you can just as easily select a block of code and run it. And it also obviously works in source code files. So if you have a .py file and you want to run it interactively here in JupyterLab with all the rich output that the Jupyter architecture provides, that will just work. So we've got that. One of the big ideas of JupyterLab is extensibility. And one extension point that we've provided is for different file handlers, both editors and viewers. And I've shown you some of these. Another example is here of an image. I can double click on an image and that's going to immediately open. The image viewer that we have is not particularly sophisticated, but does have keyboard shortcuts for zooming and panning, and then resetting the zoom level. Other formats, I guess here's one that is particularly relevant in this context. Here's a GeoJSON file. We have an extension that uses leaflet to render GeoJSON data. And once you install that extension, literally all you have to do is double click on the file and you're going to be able to view the GeoJSON data. Another example that I'll show you here is Vega Lite is a declarative visualization specification. And so this is just a JSON file, and I can actually type open with editor here. And so now I've got, let's actually put the visualization over here. I have the actual text file that declares visualization in JSON, and the visual representation of it. The same live editing that worked in the Markdown file also works now with this visualization. And so I can edit the mark type here from a point to a filled circle, and the visualization updates in real time. And so again, this idea of well-specified models and multiple views attaching to them is something that works independent of the file type. It's not something that you have to add on a per file type basis. Another nice example here. So the original CSV file, well, here's a slightly bigger one. I think this one that I'm showing you is 10,000 by 10,000. And notice that the scrolling here, it's fully interactive, smooth. And just to show you sort of how far we're pushing this, this file right here is, I'm pretty sure it's 1.3 million rows. And if I had a little more time, I'd actually just try to open this in Excel for you. And the result of trying to open it in Excel is that Excel is unsuccessful. You actually can't open the full file. Excel ends up truncating the rows. And even the subset of the file that Excel opens ends up barely working. It's very, very painful and slow. And so here we have 1.3 million rows opened, and the scrolling is completely smooth. And it's there's a lot going on here. Obviously, in this case, we're still transferring the full file to the browser. we are starting to work on a set of data APIs that allow such files to be loaded incrementally on demand. At one of our recent sprints, someone got this working with incremental loading of HDF5 files, for example. And so that's a very active area of research. And we have, I don't actually have it running right here, but we have an example of our data grid called the Keep Us Honest data grid. And I should mention Chris Colbert, one of our lead folks on JupyterLab, has written this data grid and has done an amazing job with it. But the Keep Us Honest example actually has 1 trillion rows and 1 trillion columns. Obviously, it's not in memory. We generate the data on the fly. But from the UI perspective, we're able to handle essentially arbitrarily large tabular data sets. Let's see here. What else? Oh, I guess another aspect to mention of sort of the data integration, or the integration between different things that we can provide. So for example, if you have 2 notebooks, you can, in JupyterLab, actually take a cell and just drag it to another notebook. And this already, I've started to use this a lot for just my own work and teaching and so on. And sort of being able to move content around easily between notebooks is extremely valuable. We also have the ability to hide input and output. So here's an example of hiding output for a cell, but you can also click on a cell and then hide the input for that cell. This is something that is very helpful both from the development perspective. Oftentimes you have large blocks of code or large outputs that you want to temporarily hide. It's also valuable in presenting notebooks to different audiences where the audience may not want to see all of the code. So for example, notebook, I can hide all code, and now I've got a simple version of that notebook that is really more like a narrative where you see the results of the code, but not the actual code itself. What else do we have here? One of the things that people express that they really like about the classic notebook is the simplicity and being able to focus on a particular thing, one document at a time. And so what we've done in JupyterLab for that is we have something called single document mode. Right now it's bound to a keyboard shortcut. Oops, there it is, sorry. So it's Command-Shift-Enter or Control-Shift-Enter. And I can now focus on a single document. I can see my open tabs here, so I can still switch between documents. The nice thing is that when I'm done, I can hit Control-Shift or Command-Shift-Enter again, and the layout of the multi-document doc panel is still remembered. We have a command palette. So this is basically a text-oriented way of accessing functionality in the system. So if I want a new terminal, I can hit Command-Shift-C and type new terminal, and we've got fuzzy searching. Let's see, what else do I want to mention here? I think, there's more things I could show, but I want to leave time for a lot of discussion. I guess the last thing I'll mention is this. As an extension, so this is not built into the core of JupyterLab, we have developed integration with Google Drive. And this really shows the power of the way we've built JupyterLab to be extension-based. And so if I have notebooks, text files, etc. on Jupyter, on Google Drive, I can double-click on those and they open. And then the full real-time collaborative editing experience that Google Drive offers can be done here with text files, notebooks, everything. And doing real-time collaboration with yourself doesn't really work, and so I can't do a great demo by myself. but you could have multiple people working on notebooks, working on Markdown documents. We have built-in chat here that's on a per document basis, so you can sort of chat about documents. Our chat is actually based on just Markdown cells, and that includes LaTeX, and then it's easy to drag content out of the chat into notebooks, for example. And again, this Google Drive capability is just an extension. Our core team has built this. One of our postdocs at UC Berkeley, Ian Rose, built that. But that type of functionality can be built by pretty much anyone at this point. Even our core sort of building blocks of notebooks, terminals, text editors are all actual extensions. And so it's a highly extensible system that's sort of one of the main design goals of JupyterLab. And honestly, at this point, I think it's probably best to just open it up for discussion. I have other things I can show along the way and that we can talk about based on folks' questions.
Well, okay, so maybe before we open it up for questions, I'll take my, you didn't talk about something that I thought was particularly exciting. I think maybe it was at SciPy 2 years ago, or maybe just last year, this year, which was the ability to basically take widgets that were in your notebook and sort of assemble those into what would look like an application, sort of like and then actually, I think you said that you were working on how to publish that to the web so that you could have sort of a, basically create your application in the notebook, essentially sort of hide the code or reassemble the widgets into one panel or something, and then kind of have a way to publish that. Or could you talk about that whole side of things?
Yeah, there's definitely a lot of work that we're thinking about related to that. The initial thing that we've done along those lines, and actually it's not in master right now, we're refactoring it, is that you can actually take a single cell or output and drag it out into the doc panel. And it's sort of a mini lightweight dashboarding capability. Currently, there's no real way of persisting that into something that you could publish. This bigger idea, though, of taking notebooks and parts of notebooks and assembling them into applications or dashboards or reports is something that we're thinking a lot about. And at this point, most of that work is going to happen after our 1.0 release. But it definitely is like that's one of the main usage cases for an environment like JupyterLab, and that you could imagine assembling cells from multiple different notebooks attached to multiple different kernels, possibly in different languages, into some sort of application or dashboard that you're able to publish to other people and have them use it without needing to know about the underlying code and notebooks and so on.
Okay. All right. Thank you. I'm gonna unmute everybody. Hopefully it doesn't get too crazy. So everybody should be unmuted unless at least by me. So you might still have to unmute on your end if you've muted yourself. But does anybody else have some questions for Brian?
Yeah, this is Roy. Can I ask a bunch? First, can I confirm that you do still support widgets in this?
Yes, the classic IPy widgets, which we're now calling Jupyter widgets because multiple languages are working with them, are supported. At this point, and they're supported through the same extension mechanism because right now we're releasing JupyterLab about every 2 weeks. We're pre-beta. And what that means is that we're breaking things quite often still. And so for some releases, the Jupyter widgets aren't updated to the latest version. I think the current version of JupyterLab does have a version of Jupyter widgets that works fine with it, though. And so...
Okay, I'm sorry. My second question is, RStudio is adding a lot of similar features. I mean, this is very impressive. Is there any talk or collaboration between you guys and them? I mean, it seems like duplication of effort.
Not a lot of talk. Yeah, I mean, that we're obviously we're aware of what they're doing. They're aware of what we are doing. I think it's important to mention the big vision we have with Jupyter, and that is, yes, we're building applications such as JupyterLab or JupyterHub. The more important thing is the architectural foundations. So the open standards, the open formats, the network protocols, and our experience is that it takes a lot of time to build those things. And honestly, we move very slow in many respects, or very slowly in many respects. At the same time, what we've seen over time is that the multiplicative effects that you get in the long run by building sort of solid architectural foundations really pays off. And so all the live rendering and the real-time collaboration stuff we're getting in JupyterLab is one example of that. And I think that's our main focus. What that means, though, is that there's a lot of sort of really nice things that RStudio has that we don't have yet. I mean, the whole R Markdown rendering experience, Shiny integration and deployment even, I mean, they're fantastic. They're absolutely fantastic. Ultimately, Jupyter and JupyterLab and RStudio are serving largely the same types of users. There may be some small differences in terms of the types of people that are using R versus languages that are popular in Jupyter. Even though Jupyter supports over 100 different languages, our observations of data on GitHub, for example, indicate that almost 100% of our users still use Python. So it's a very small fraction that are using other languages such as R or Scala or Julia in Jupyter. But there's definite overlap there, and also exploration. I mean, RStudio recently has come out with their R notebooks, and it's a slightly different way of envisioning what a notebook might be. We're going to continue to support Jupyter notebooks, but at the same time, we want to provide building blocks that allow people to explore different ways of doing these things. And so, with our current Markdown support in JupyterLab, you essentially end up with something like the R Markdown experience. And so there's a lot of exploration, both from RStudio and Jupyter around these ideas.
Yeah, two more questions if I could.
Oh,
can I ask two more quick ones?
Yeah, can I just interject, though, that in the chat there, Philippe chimed in and said, from a user perspective, I guess one could easily use R within JupyterLab or combine different languages within JupyterLab, but the reverse is not true with RStudio.
You can do Python now with RStudio.
You can?
Yeah.
Okay. So you can.
I mean, they're both great. It's not I'm just curious because there's so much overlap. I noticed also the Beaker no longer is making an independent notebook. It's now an add-on to Jupyter. Is that tightly integrated with you guys, or is that their own project?
Yeah, we are working with the folks at 2 Sigma very closely. Currently, they're targeting the classic notebook, but it's our understanding that as we migrate everything to JupyterLab, that they're going to follow that and embrace JupyterLab as their front-end user interface, in addition to embracing all the back-end architecture for kernels and notebook documents and all of that.
And my final is, given this community, you seem to imply that there would be support somehow to view NetCDF files. Is that true? That would be neat. Or is that easy enough to add?
it shouldn't be a problem. I mean, there's obviously work to do, but all the different APIs needed are there. It really depends on sort of what you want to do with those files. But yeah, I mean, we have other extensions at SciPy. One of our core developers and a grad student wrote a file viewer for the FASTA format that's used in bioinformatics, and I think that took them, I think they said it took 8 minutes to write the extension. It was something silly, but there was an existing JavaScript library that could render FASTA, and so packaging that into JupyterLab extension was quite easy.
Okay, thank you very much. Interesting talk.
Thanks.
Okay, there's Tyler has a question in the chat. What is the roadmap for geospatial functionality?
You might be able to hear me now. I just switched microphones, so I'm not actually sure whether I'm still.
Yes,
yeah,
I do hear you.
Yeah, go ahead.
Yeah,
This is sort of just a leading question because I know a little bit about it, but given this audience of ESIP, I would think there'd be a strong interest on not just the NetCDF data formats, but other geospatial data formats, analysis and visualization. Do you view that Jupyter will be trying to support that directly, or are you expecting another community to kind of build extensions for JupyterHub to support geospatial use cases?
Yeah, I think in the long run, our focus needs to be on sort of the minimal subset of functionality that everyone needs, and then robust APIs for people to build extensions. I think probably where the concerns of this community overlap with other work that we're doing is thinking carefully about APIs to expose different types of data in the front end. And so currently we're starting to think about just basic tabular data sets. So you can imagine, if I have a CSV file, I'd like to double click on that, even if it doesn't fit in memory, to get a lazily loaded view of the data. Maybe we're converting to another intermediate file format or in-memory format along the ways, and then making that available to different things in the front end, maybe visualization tools, maybe the data grid. And that sort of data API substrate, I'm guessing for this community will also be relevant. I think the challenges there are that I'm guessing that the structure of the data is going to be specific to the types of things you're doing with the geo data. And so, I think it's going to be something that we're willing to work with this community, but that a lot of the actual work would need to be done outside the core Jupyter team.
Makes sense.
Okay. Let's see. There's a couple more questions in the chat. Brian, can you see those?
Let me pull. I had minimized the chat. Yeah, let's see. Chat. All right. Yeah, there's IPy leaflet, which in combination with IPy widgets provides a robust base to develop such geospatial-oriented widgets. Yeah, so IPy leaflet is a Jupyter widget for working with geospatial data, and I mean, I'm the original creator of IPy leaflet, and actually it's similar to the GeoJSON handling that we have in JupyterLab now. Our hope is that this encourages communities interested in these things to jump on board and help us develop them. They're sort of very early prototypes that are hopefully useful to people, but we recognize that people actually doing work in that field will need much more than that, but we're hoping that they sort of spawn participation. And then let's see, also someone commented, check out HoloViews and GeoViews for some neat geospatial visualizations in your notebook. else.
I think that might be it.
Yeah, and then, yeah, there's a comment about NetCDF being sort of too general and diverse of a data model to represent it visually in a simple way like GeoJSON. I was actually just in another meeting right before this having the same discussion about HDF5 in general, that yes, parts of an HDF5 may be a tabular data set that you could pull up in a data grid or spreadsheet, but in general, it's a much more complex data format with metadata and hierarchical structures. So,
this is Ted Haberman from HDF. Thanks for a great talk, Brian. I mean, the thing in either NetCDF or in 100 other dialects of HDF is community-dependent data types are defined on top of the general structure of HDF. So things like that would be where this would be interesting. And Andrew Collette did some work with a browser he called HDF Compass that we've also been using, which was built around that idea of having communities have data type specific browsers built on top of HDF5 in a fairly open framework. And it would be really interesting to think about some of the stuff that Andrew did with HDF Compass in this kind of context.
yeah, and I mean, we're seeing that type of pattern across a wide range of different usage cases. Another great example is the astronomy and astrophysics community is building sort of special viewers for astronomical data. And I think the common pattern that we see there is that there's sort of core logic, either in the user interface or at the data level, that those things implement, but there's a bunch of other stuff that is difficult to implement. So for example, you typically have to write your own server for that, or you have to figure out, okay, how do we integrate with the file system? And it's sort of that substrate that we're hoping to provide in JupyterLab so that someone can come in and say, all right, I already have the ability to render this data, and there's a file format that someone specified. How do I just plug it into JupyterLab and have everything just magically work? And so that we're seeing that same pattern across many different communities right now.
Yeah, everything magically working. That's a good goal.
We'll see how magical it is at the end of the day. Yeah.
All right, anybody else? All right.
Maybe a question in the chat here. I work with people who can modify a little bit of code but aren't going to write their own standalone scripts. Would you recommend JupyterHub and or JupyterLab for a team to collaborate on shared notebooks? So right now, yeah, JupyterHub is our multi-user notebook server. Today, JupyterHub doesn't have any collaboration features other than allowing multiple people to access notebooks on shared compute resources. And there's two directions we're going with collaboration. One is file-based sharing. So we've started to work on a JupyterHub extension that we're sort of temporarily calling Hub Share, that basically allows users on a JupyterHub instance to publish notebooks to other users who could then view them or run them themselves. And so it's sort of slower timescales than real-time collaboration, but also not forcing people to collaborate through Git when that doesn't make sense. The sort of ultimate goal is to have real-time collaboration supported. That's still fairly early on, and we've not really played with deploying that on JupyterHub yet. For people who are just coding a little bit and wanting to collaborate, I'm guessing the user experience of actual real-time collaboration is going to be probably optimal. Today, though, with the JupyterLab beta, you can actually use the Google Drive plugin for JupyterLab and do real-time collaboration without ever installing JupyterHub. And so that is an option where users could just have files on their own file system, and then the collaborative files stored on Google Drive, and run just everything locally. And that does work.
That's interesting. Brian, did you want to say something about, you mentioned something about Binder earlier on. Did you want to mention Binder, or did I miss it? Did you already talk about Binder somehow?
I've not talked about it yet, and I'm more than glad to talk about it. The idea of Binder came out of Jeremy Freeman's group, and the sort of vision of this is that a lot of people are putting their notebooks up on GitHub, and GitHub is for a number of years supported the viewing of sort of statically rendered notebooks on GitHub, but obviously GitHub isn't in the business of allowing people to run notebooks on their infrastructure. And so the idea of Binder is to point to a GitHub repository that has a file that declares the dependencies needed to run those notebooks, either a requirements.txt or a conda-n file, or even perhaps a Docker file. And then what Binder does is basically on the fly build a container that has all the content of that repo, all the dependencies required to run the content, and a live running notebook server for that. And so Binder came out maybe a year and a half ago, 2 years ago, and our team, our JupyterHub team, has been working to basically refactor Binder using all the different building blocks that we have in JupyterHub. And so we're getting close to being able to release that. And we really want to use this to push the idea of sort of finding an atomic unit that allows for the reproducible sharing and running of code. And so that's the idea of Binder, and I can show you just a simple example here. So here's the current beta, so I can just come here and enter a org or username and a repo. So this is the LIGO binder that one of our developers, Min, Reagan, Kelly, put together for the LIGO collaboration that observed gravitational waves. You can specify the branch, and then you click launch. And again, anyone in the world can do this. All you need is a web browser. It's currently being hosted on a Kubernetes cluster on Google Cloud. And again, it spins up a notebook server with all the content, everything required to run those notebooks. And then I think what I want is index.ipynb. And then it's a big notebook, sorry. So this is one of their notebooks that reproduces their full signal processing pipeline for one of their events that they observed. And I think you can see they reproduce all the figures from the publication, the analysis. And it basically is a way of making notebooks not just viewable, but runnable with all their dependencies and context around that. And so we're really excited about sort of the idea of Binder and enabling people to start to share in different ways notebook-based content.
Brian, who's paying for the Google resources, or is Google providing those for free?
That's in the middle of transitioning right now, and I don't know the answer to it today. The original funding for Binder came from Genelia Labs, where Jeremy Freeman's group was. He's now working for the Zuckerberg-Chan nonprofit foundation on their science program, although he's no longer actively involved the development of Binder, sort of collaborating with the JupyterHub team, advising the project with us, but not working on it directly himself.
And I only asked that because, you know, you wonder how stable it's going to be. Like, could you use Binder for, you know, some training or whatever? Could you depend on it being there? If you can't depend on it being there, is it easy to install it on your own infrastructure?
Yes, that's part of what we're working on, is making it really easy for many people to host Binder instances. But the current implementation in this beta release is much more robust than the original version. The JupyterHub team has spent a lot of work on just testing JupyterHub in general, load testing it, stress testing, and now the big question though is just cost, right? And at some point, the sort of canonical hosting of it will probably run out of hosting resources, and it's an active problem we're thinking about. And it's one of those situations where, as we relaunch Binder and encourage people to start using it, if we're successful, this is going to become a significant problem that we have to tackle and figure out. Because I mean, we're hoping that lots of people want to use it. That obviously costs.
Right. Okay. Well, I think maybe this is a good spot to thank you, Brian. And this has been really super interesting, and it's going to be exciting to see where you guys are going in the future. Actually, how much more funding do you have at this point for JupyterLab development? How many? Are you good for another year, or how's that?
It's a fairly complex question in that our funding for Jupyter is not centralized. We have funding on the academic side at Cal Poly, where I am, and then at UC Berkeley, where Fernando Perez is. Our academic funding goes, I think, for about another year and a half. And so we're doing okay on that front, but all starting to think about what it would look like beyond that. And then we also have other people participating in the development of JupyterLab, in particular Bloomberg and Continuum, which has recently changed its name to Anaconda.
Right.
And they have their own funding cycles and so on. But
sure.
Okay.
Well, thanks again, Brian. That was great. And thanks everybody for showing up. And we'll see you again next month. And this recording should be up by tomorrow morning. See you later.
Thank you. Thank you so much for having me.
Thanks, Brian.
Thank you.
Thanks, Rich.